So we're now going to discuss the proof of the product rule for the derivative. I'm not going to give the full proof, but I'm going to give you the main ingredients and then challenge you to work out the rest of the details yourself. So what does the product rule say? Well, it says basically that if I have f of x times g of x and I take the derivative, then what I'm supposed to get is the derivative of f times g of x plus f times the derivative of g of x. What are my assumptions? Well, my assumptions, what I'm allowed to use, is that f and g both have a derivative at x, so that these two things here both exist. Now, the basic logic here is to make a chain of equalities that connects these two sides. And the first step would be to write out the definition of this. So that's lim h goes to 0 of f of x plus h times g of x plus h minus f of x g of x. And now the question is how to move from here to here. Now the tools we are allowed to use here is basically the rulebook for the limit. So that's one thing. And the second thing is an observation that comes in the textbook just before this, and it's the fact that if f prime exists at a point, this implies that f is continuous at x, okay? So this implies that if you have lim u tends toward x of f of u, this gives you f of x. Basically, if you have anything inside of here tending towards x, you can just replace all of this by f of x. Now, a difficulty is that by these assumptions, we know that, say, f of x plus h minus f of x divided by h, if I take the limit here, as h tends to 0, well, this has a limit, and this limit is this thing here. And similarly for g. But here I'm having this product, and that's annoying. So how to get this guy paired with that guy and this guy paired with that guy separately? Now, there are algebraic tricks here, so you can add and subtract by 0 in a clever way. Or you could arrive at the same trick, but geometrically. And that's what I'm going to explain now. So how to figure out how to make a good rewrite of this by using geometric intuition. So what we can do here is we can think of f and g as positive. And let's think of f as follows. So let's say you have a coordinate system here, which describes the farm of some farmer, okay? And let's say that here is a corner of his farm, and then here is how far out this field stretches at time x, let's say day x. And here we have how far his farm stretches in this direction at day x. Now, this may seem a bit preposterous because his farm should be the same size every day, right? No. But this is a clever farmer. So when the time has increased by age, so you have f of x plus age, he's been out every night moving his fences a little bit to the side, okay? So his farm actually increases in size in this direction. And similarly here, every night he's out to move his fences a little bit to the, let's say, north. So after age days, we have gotten this increase in size here, and after age days, we've gotten this increase in size here. So what's the new size of his field? Well, it's this thing, right? And now the point is that this expression here computes the rate of change of this two-dimensional object, okay? It's the rate of change of this area. And this thing here is his old area, and this thing here is his new area. And what's the trick? Well, the trick is to use a different color. Well, the trick is to split these two areas into a green one here, say, and then let's say a purple one here. Now, if you express the purple area here, and then you add the green area like this, then together these two guys should be equal to this thing here, which was just the overall increase in area. And if you now do the purple area divided by age and the green area divided by age, well, guess what? You're getting these two contributions here. So this, if you follow this logic and you try to write out what these expressions are, I mean, here you have the height of the purple area would be the difference of these two guys, and the width of the purple area is just this guy, and similarly for the green one. You'll get expressions here, and then you can compute them, and you will get this thing here using the rulebooks for the limit and the fact that f and g are continuous at x, since they're both differentiable there. So good luck in trying to kind of work this out. It's, I think, a good exercise to do it, and I think it'll help your understanding. So go for it.